Hello everyone, welcome to this course on complex analysis, and I am your instructor Kaushik and I am from Department of Mathematics IIT Kanpur. So essentially this is your NPTEL MOOC course, and we have a 12-week duration course on complex analysis which is around 30 hours for this particular instance. And the idea is this is a course which is designed for BTech and BA students who are working on electrical engineering, aerospace, mechanical, even physics students doing their BS or civil engineering. Now, of course, the others can also use. There is another thing which I really want to tell you that maybe some math students who just want to brush up their preliminaries can also look at this course. Okay, let us just understand what the idea of the course is. Essentially, what we are trying to achieve here is just to give you an idea of what complex numbers is, how they interact, and how to do, the derivative and integration in this complex plane. So more or less, all of you have some idea of what complex numbers is. That is essentially your, if you think of as a set, it is R2, right? So we'll start with this and we'll try and understand what is the different, what does R2 and C has in common and what are the differences between those two, and how that difference actually gives you this very rich theory of complex analysis. Okay, otherwise you can just start it, do several very well calculus and you are done, right? Why we are doing this thing? We will first try and understand this in this first section, which will be your complex numbers and complex algebra. Okay, the second part we will talk about differentiation. This is where we will see that the complex multiplication plays a huge role, and this is where the theory of R2 and C becomes totally different. So we'll talk about the derivative, the concept of derivative. There is something called CR equation. We are going to talk about that, and then we'll do power series of a function, complex function of course, and we'll put everything together in a one simple thing. So essentially derivative, CR equation, power series, all of them actually will give you a single concept. Okay, now next which we will do is we will look at complex integration. Now this is the most fun part and extremely rich theory. So what we are going to do is we start with Cauchy's theorem. It's not a one theorem, it's just for different cases there are many different things which you are going to study. That is your Cauchy's theorem. We will go to something called a Liouville theorem. This is also a very excellent representation of what complex analysis can do. So essentially what you have is, if you have the entire domain C, and if you have a function, okay, which is an entire function, we will talk about what entire functions are. Essentially think of it like a different derivative function which has a derivative, that sort of function. And if you have some sort of function which is like differentiable everywhere in C, and if it is non-trivial, then this is going to be constant. So that's your Liouville theorem. It's a very nice theorem. Lots of applications are there. We want to look into that, along with something called a maximum modulus theorem and Schwarz lemma. Okay, there are of course other things which are going to do, but these are just the idea. And then we are going to look at something called a Lorentz series. This is also again a very important topic in complex integration. And we'll finish it up, this particular section, with something called residue calculus. You will see that many different complex integrations can be done using residue calculus in a much easier way. Okay, right. And here we will talk about all these poles, singularities, all these kind of things. Yes, I forgot to write that part, but there will be some discussion on poles, singularities, this sort of thing in this particular section. Okay, and the last section, this is for this particular course, this is not going to be extremely detailed. What I am going to do is I will give you ideas of what exactly these are, how to work with those things, but we are not going to delve deep into the theory part of it, because that is not this course is. Okay, so what we will do is we will talk about something called a conformal map, that is angle preserving maps. We will talk about that later in the course. and then we'll talk about something called a Mobius transform, again extremely deep theory, and we'll talk about something called a Riemann surface. This is just a brief discussion we'll do Riemann surface, because for this course I think that if you are doing Riemann surface, everything will actually we can put together everything, and I mean give you a much richer understanding of what this complex analysis is. If we can go to that particular thing called Riemann surface, we'll just give you a small idea of it. So this is just the idea of what that course is, and I think, I mean, if you are really interested in understanding what's happening in this course, you will really like this course. It's a very, very interesting course, and I hope you will learn. And in case of any doubts, you can of course contact me directly at this email, this ID, Kaushik at iitk, okay, .ac.in. Please do that. So this is the email ID. Of course, there are TAs also. You can contact them in case of any doubts. And I hope you enjoy your course. Thank you so much. Bye.